Hey guys, so today we're going to do chapter 4, section 3, which is all the different properties about logarithms and how we're going to manipulate them algebraically and solve and things like that. So there's a lot of different rules, but they're not difficult rules necessarily. It's just going to be getting used to them. So just like you can add, subtract, multiply, and divide with numbers, you can use those same principles with logarithms. And so we're going to learn how those work. I have pulled up my notes and I'm going to leave them up. Remember, you always have access to my notes and are more than welcome to print them off as well, or copy notes as I do, and I will work the problems on the board as we go through the notes. So the first rule we're going to learn is the product rule. If you see the word product, that means multiplication. So if we let b, m, and n be positive real numbers, that's going to be the start of all of these rules. And obviously b is not 1. You don't want the base to be 1. Then the log of base b of m times n, so of two things being multiplied together, you can expand that to be written as log base b of m plus log base b of n. So you can write the product of two different numbers or two different expressions as addition of these two different logs. And so what we're going to do is we are going to work those problems. Now, obviously, if I have my notes pulled up, then you have the answers right there in front of you, but you need to pay attention to what I'm doing on the board if you want to really understand how to use this principle. And I've written the principle on the board as well, so that when we are asked to expand, notice it doesn't say solve, it doesn't say evaluate, it doesn't say compute, it says to expand. So we are not going to get an answer. We are just simply going to use the product rule that we just learned to expand or write this out in a longer form. Okay, so be aware of that as you're going through your problems today. So the first one we have is log base 4 of 7 times 5. So based on our product rule, we can write this as log base 4 because the bases stayed the same. And then we're going to put the first product, the 7, and then we put a plus, and then log base 4 of 5. We have now expanded that logarithm from log base 4 of 7 times 5 to log base 4 of 7 plus log base 4 of 5. That is what the product rule allows us to do. So let's go on to B. B says log of 10x. So we're going to expand that. So we have log of 10 plus log of x. But here's something to be aware of. Notice that on this one, we didn't write a base, right? We just wrote log. And so what is the understood base if we don't write a base? Well, it's base 10. Do you remember that? That's like saying log base 10 of 10. And what happens when the base and the thing that you were logging are exactly the same? That means it's all 1. Remember, let's put a little star down here and let's note that. Log of b equals 1. So if the base is the same as what you are logging, then it simplifies out to 1. So while we are not computing or evaluating or solving for these, we do want to make sure that we simplify them as far as we can. So log of 10 is the same thing as saying log base 10 of 10, which is the same thing as saying 1 plus log of x. So you do want to simplify it even if we're not solving for it, okay? So that's how we use the product rule in order to expand our logarithms. So let's slide down. The next rule that we are going to learn, which is right here at the bottom of the page, is the quotient rule. If you see the word quotient, you should think division. So again, like I said, that first line is the same for all of them. Let b, m, and n be positive real numbers and b not equal to 1. So you're taking the log of something. So if you have log base b of m divided by n, then you can look at that or expand that to say log base b of m minus log base b of n. So with the product rule, with multiplication, we were adding. With the quotient rule, we are subtracting. Okay. Again, we are going to expand. We are not solving. We are not finding the solution. We are expanding. We have log base 7 of 19 divided by x. So based on our quotient rule, we write the top, our numerator first. Same base, so log base 7, and then write our numerator of 19. Then we put subtract log base 7 of our denominator, x. That's as far out as we can simplify it. So we've done it. We're good to go. The second example says ln. Remember, ln is our natural log. That means it has a base of e. So we have ln of e to the 3, the third power, all divided by 7. So I have ln of e to the 3 minus ln of 7. Now, very similar to what just happened over on B on our first examples, or like right here, we had the base was the same as what we were logging. Natural log says we have a base of e. So that means we have the base and what we are logging are the same again. So here's a little note. ln of e to the x is simply x, no matter what that x is. So if I have ln e to the third, then that's going to simplify into 3. And then we have the minus the ln of 7. Again, we're not going to compute this where we're getting an actual number, but we do still want to simplify it as far as we can. So this is a good thing to note. Here in just a minute, we're going to learn the power rule. Actually, it's our next rule. And this will make a little bit more sense as to why this works. Okay, so product rule, you add. Quotient rule, you subtract. The next rule is the power rule. The power rule is with exponents. You raise it to a power, so you have your power rule. The power rule says you have log base b of m raised to some power. Then you can simplify that, or you can expand it rather, to where you pull that power out front, and then you have log base b of m. So we pull the power around to the front of our logarithm. So we're going to do 3 examples. We have log of 5 of 7 to the 4th power. Based on the power rule, we pull that power down to the front. So it'd be 4 times log base 5 of 7. Okay, what about this next one? ln of the square root of x. Well, you might be saying there's no power there. Well, it's because we need to write the square root as a power. We have talked about this. We talked about this a lot in 4.1, where you can write it as a rational exponent. Remember, this is like there's imaginary 2 there and imaginary 1 there. So that would be the ln of x to the 1/2. Now we can easily see the power rule come into play where we pull that 1/2 down front, and you're left with ln x, like that. Okay, last example of this one, we have log of 4x raised to the 5th power. Power rule says I'm going to pull that 5 down front, and then I still have the log of 4x. Now here's a question. Is this completely expanded? If we're only talking about the power rule, yes, it is completely expanded because we pulled the power out front. But if we were to expand it completely, then no, because we have a product happening in here. So we need to expand this further using the product rule. Okay? And the way that we would do that is you could do 5 times log 4 plus log x. You could write it like this, or you could distribute that 5 to both of those logs. Either way would be correct. So if we were only expanding by the power rule, we could stop here, which is what I did in my notes. But to fully expand it out, we would need to use the product rule as well. because we're not just learning these rules to use them individually. We're learning these rules so that we can use them combined together. Okay, so we've learned the product rule, the quotient rule, and the power rule. Now we are going to combine all of these rules together in order to simplify some more complex logarithms. We're going to be doing multiple steps, multiple rules with these. And I can scroll up so you can see. Well, I don't really want to give away the answers. So you can see from right here. We are asked again to expand, not solve. We have log base b of x squared times the square root of y. So the first one that I'm going to do is I'm going to do the product rule. I have x squared times the square root of y, so I'm going to expand that using the product rule. So that becomes log base b of x squared plus log base b of the square root of y. Now I have my power rule. I can bring my 2 out in front. So that's 2 log base b of x plus log base b. And then I need to write this not as a square root of y, but as y to some power. And that's y to the 1/2 power. Then I can do the power rule again for the second bit to pull that 1/2 out front. So the 2 log base b of x stays the same, but then I have plus 1/2 log base b of y. Now it is fully expanded. I can't bring anything else out. I can't do anything else. I can't simplify anything else. So that's as far out as I can take it. Okay. Let's do another example. There's that first one for you. Right there. Okay. Now we have log base 6 of the third root of x divided by 36y to the 4th. So definitely a lot more going on in this one. That's okay. We can do this. So the first one I'm going to do is I'm going to use our quotient rule to separate up this division. That's going to give me log base 6, and we put the numerator first, the top, the cube root of x minus log base 6 of our denominator, which is everything that's on bottom, 36y to the 4th. Okay, I'm going to write this third root of x as x to the 1/3. I needed to get a rational exponent. Remember, there's a 1 in here. The numerator is always the number that stayed with your base. The number that was out front of your radical is always the denominator. And I have minus. Now over here, if we look at this, I have log base 6 of 36 times y to the 4th. So I have a product rule going on over here that I could go ahead and expand out. So I'm going to do that. And I'm going to use a big set of parentheses so I don't forget what's going on over here, that all of this stuff was in the denominator. So I have log base 6 of 36 plus log base 6 of y to the 4th. Okay, I have the power rule, so I can pull that 1/3 out front. So that's going to be completely expanded now. Log base 6. Now here's something that you have to kind of teach yourself to look for. Because remember, if the base down here is the same as what we are logging in here, then it's going to simplify out to 1, like we've done already. So if you are doing log base a number of a number, we need to say, is there a way I can write the number in terms of the base? So is 36, can I write that as 6 to some power? Because if so, I'm going to be able to simplify it out really, really, really quickly. Well, yes, because 6 squared, or 6 to the second power, is 36. So I'm going to say log base 6 of 6 squared. I'm going to rewrite it like that so that I'm going to be able to simplify out even more, okay? Plus, and then I have the power rule over here where I can pull that 4 out front, of log base 6 of y. So I have 1/3 log base 6 of x. And then remember, if the base and the base are the same, then that all goes to 1, and I'm left with my power. Because that 2 is really going to come out front, and it's going to be 2 times 1, which is 2. So that's minus 2 minus 4 log 6 of y. Notice I distributed that negative inside this parentheses. So I had a minus log base 6 of 6, 2, and minus the 4 log base 6 of y. There's nothing else I can simplify out. That is the final answer. So this base to base thing is something you're going to have to watch for. And it's something that I made a special note of in your notes right here. Log base 6 of 36 can be written as log base 6 squared, which equals 2, because of the base of x equals the 6 squared. Or you can think of it like this. Log base 6 of 6 squared. With the power rule, that'd be 2 log base 6 of 6. And anytime you have log with the base, the same as what you are logging, that's going to go to 1, which just leaves you with 2. So you can think about it in whatever terms helps it to click in your head. But anytime in any of these problems, when you are simplifying or expanding, and you have a base that is a number, and you are taking the log of a number, you need to see if you can write it in terms of each other. Because if so, then something's going to simplify out in the long run, okay? So that's something to consider. So far, everything we've been doing, we've been using these rules in order to expand. They gave us something nice and compact, and then we expanded it out. So if we can expand, then what's the opposite of expanding? Condensing. We can condense these same logarithms going the opposite direction. We do have to make a couple of assumptions. We have to assume that m is greater than 0 and that n is greater than 0, so we have to make sure those are positive. When we do the quotient rule, we have to make sure that n does not equal 0, but if it's greater than 0, we're good there. So these condensing logarithms, these rules, they're the same rules you've already had. They're just written in the reverse order. So if you have log base b of m plus log base b of n, you can condense those or combine them together using the product rule, to where you have log base b of m times n. Same thing for number 2. Log base b of m minus log base b of n equals log base b of m divided by n. That's your quotient rule. You combine them together using division. Then if you have p times log base b of m, so some constant times the log, that's the same thing as log base b of m to that power. That's your power rule. So we spent the first part of this class taking it and stretching it apart. Now they're going to give us the stretched out version, and we're going to smush it all together as best as we can. The big trick is going to be looking for these times where you are taking the base of a number. You're taking the log of a number and then needing to simplify it out some more. That's going to be the tricky step. And that step, unfortunately, like, I don't have a lot of cheats for you on that. That's kind of like factoring or foiling, whereas the more you do it, the better you're going to get at it. Okay? So we're going to condense this first one, which is up there on your screen. Log base 4 of 2 plus log base 4 of 32. So we need to combine these together. That addition tells you that you're going to use the product rule. You're going to combine them using product. So that's log base 4 of 2 times 32, which equals log base 4 of 64. Now, like I said a minute ago, if you have a base that's a number and you're logging a number, we need to see if we can write that number with a base of whatever our base is. So can we write 64 as a base of 4? Well, if you're not sure, which honestly I wouldn't be sure, this is how I would do it. I would come over here and say, well, 4 to the first power is 4. That doesn't help. That's not 64, because I'm trying to figure out if I can write 64 with a base of 4. 4 squared is 16. Well, that's not 64. 4 to the third is 64. So I can write 64 as 4 to the third, and that's what I'm going to do. I'm going to write log base 4 of 4 to the third, because then that log base 4 of 4 is going to go away and just leave me with 3. So fully condensed, fully simplified, log base 4 of 2 plus log base 4 of 32 is 3. You have to keep going with it as far as you can, okay? And sometimes it means you're going to get a single number, or you'll get 3 minus something else or whatever. But you have to look for that. You have to train yourself to look for those cases. Let's do example number 2, or B. We have log of 4x minus 3 minus log of x. We need to condense this. We have a minus in here. Don't worry about the minus in here. Worry about the minus between your logs, because that's the only way you can condense. You can condense logarithms together. So since it's a minus, that tells you it's the quotient rule. So you have log, and they always write the numerator first, so that's the 4x minus 3 over your denominator, which is the second log, which is x. We can't combine those any further. We can't simplify that any further. That is the end of that problem. So sometimes there's a lot of steps like our first one. Sometimes it's a single step like this one. Okay? C, we have 1/2 log x plus 4 log of x minus 1. First thing I'm going to do is I'm going to use my power rule to bring these coefficients up as powers before I condense them further. So I'm going to have log base x of 1/2 plus log base x, or log x minus 1 to the 4th. Now I have a log plus a log. Log plus a log means I can use my product rule. So I have log of x to the 1/2 times x minus 1 to the 4th. You don't have to simplify that any further. You don't have to distribute that. You don't have to change that to a square root if you don't want to. You can simply stop at this point. Okay? You have combined them. That's all that was asked of you. Here's that example right there. See, I didn't combine that any further. Okay, let's go do 2 more examples of condensing. We have 3 ln of x plus 7 minus ln of x. Again, if I have that coefficient out front, that tells me I can use my power rule, and I'm going to do that first. So I'm going to do ln of x plus 7 to the 3rd power minus ln of x. Now I have an ln minus an ln, so I'm going to use my quotient rule in order to combine them further. Or I have ln of x plus 7 to the 3rd power all over x. If you want the big set of parentheses, you can absolutely have those. Either way would be completely correct. You do have to be a little bit careful on how you're inputting these into the computer so that you are making sure that all of this is connected with your ln. Okay. Last condensing problem. Which is E, which is written right here if you have a harder time seeing it on my screen. We have 4 log b of x minus 2 log b of 6 minus 1/2 log b of y. One thing I don't think I've actually mentioned yet in this class is that notice all of our bases are the same when we are combining or expanding these. That has to be true. If this would have said log base b of x and this says log base c of 6 and log base d of y, we wouldn't be able to expand those or condense them any further because they have to have that same base in order for them to play together or in order for them to condense or expand together. So that is something to note. I don't think I've said that on any of the other boards, but do note that. So each of our logs right now has a coefficient. So that means I can use the power rule to bring those in, and that's what I'm going to do first. So we're going to have log base b of x to the 4th minus log base b of 6 squared minus log base b of y to the 1/2. Notice I have something minus something minus something. That doesn't mean that I have a fraction and a fraction, but it does mean that I could pull that minus out so that I can just have the quotient of one thing, which is what I'm going to do. Minus, and then that'll leave me with log base b of 6 squared plus log base b of y to the 1/2. Now, if I look inside my parentheses, I have a log plus a log. That tells me I can use my product rule to combine those together, which is what I'm going to do. I'm also going to stop writing 6 squared, and I'm going to write 36. So log base b of x to the 4th minus log base b of 36 y to the 1/2, because we combine those together. We condense those using our product rule. Now I have a log minus a log, so I'm going to use my quotient rule. Log base b, my first one is my numerator, that's my top, which is x to the 4th. My second log is my denominator, which is 36y to the 1/2. Or you can write that as the square root of y, whichever one you prefer. But it is fully condensed, so we are done with that one. And that's how we condense them. Okay. We also have, moving on from, so far we've used these rules, these product, quotient, and power rules to expand our expressions, and we've used them to condense our expressions. So now we're going to talk about the change of base property. The change of base property allows us to actually evaluate a logarithm that doesn't have a base of e or a base of 10. If you look at your calculators when you're doing these problems and you try to type in log base 7 of 4, you don't really have a way to do that right now because you either have log base 10 or you have log base e with your natural log. And so this change of base property actually allows us to compute these like log base 7 of 4 problems. And what it does is it says that log base b of m equals log base a of m divided by log base a of b. Well, what is that a? Well, really, there's two different ways. We can use the common logarithm. That's where we have base 10. So log base b of m becomes log of m divided by log of b. Or you can use your natural logarithm, where you'd have ln, like the log base b of m would be the ln of m divided by the ln of b. So this allows you to actually compute individual numbers, like I was saying. Let me show you how this works. We don't do a ton with this, but it's nice to have this tool in our belt for later on. Let me write. We're going to evaluate doing it both ways. We're going to use the common log and we're going to use the natural log. And we're going to evaluate the same log so you can see what happens. We have log base 5 of 140. So we want to evaluate log base 5 of 140 to actually figure out what number that is equivalent to. Well, we can't just type that into our calculator, like I said. So we're going to use our change of base property and we're going to see what that equals. And we're going to do it using the common log first. So the common log says that we can have log base 5 of 140, and we can evaluate that by finding the log of 140 divided by the log of 5. If you type those into your calculator, rounding to 2 decimal places, you get 3.07. Because you have the log base 10 of 140 and the log base 10 of 5, and that'll give you 3.07. Now let's do it with the natural log. Again, we have log base 5 of 140. If we use the natural log to evaluate, then we have the ln of 140 over the ln of 5. On your calculator, you have an ln button. You can type that in. And if you do, you get 3.07. No matter which way you do it, no matter if you use the natural log or the common log, you're going to get the same answer. So that's one of the nice things about the change of base is it doesn't matter which way you prefer to do it. Obviously, if your homework says use the natural log, then use the natural log. If it says use the common log, use the common log. But mathematically, you're going to get the same solution either way that you do the work. And so that is nice. And that allows you to evaluate these different logs that have different bases that aren't in 10 or an E. And that is the end of 4.3.